So, you've decided to make a React app, which means you're going to build it with the help of React hooks. The only problem is, there are a lot of different hooks. So, which ones should you use? Let's answer that question by looking at all the hooks and see what each one does, all the best ways to use each hook, and how often you'll need to use them a lot, rarely, or almost never. Here's a neat trick to make learning hooks much easier because there's actually a convenient pattern to how all the hooks fit together. I've created a complete map of React hooks to show you all 8 major categories that each one falls into, starting with state management hooks to work with React state, effect hooks to perform side effects, ref hooks to reference JavaScript values or DOM elements, performance hooks to improve app performance with memoization, context hooks to read from React context, transition hooks to use transitions for better user experiences, some random hooks, and some powerful new hooks introduced in React 19. And we'll begin with the hook you'll likely use the most. Now, useState is probably the bread and butter of any React developer, because unless you're using a framework, you'll use it a lot. A big reason why React exists is to help us manage state and re-render components when state changes. UseState is best for client components that need their own simple, specific state. And there are so many cases where we need to manage state in React, UseState is probably the most versatile hook we'll cover. To use it, you can give it an initial value, which can virtually be any JavaScript value. And that will then be stored in your state variable that's returned when you call useState. It's returned in an array which can be destructured as 2 separate variables, where the first one is the state variable and the second is a function to update that variable. UseState is great for capturing user input in form fields like inputs, text areas, and selects. It can be used to show or hide components like modals, tooltips, or dropdowns when you give it a Boolean state value. You can also use a Boolean state variable as well to conditionally apply classes and styles. And working with number values like in a shopping cart or counter is another perfect use case for useState. useReducer is another state hook that's useful for performing more complex state management than useState. You won't need to use it very often, but it's worth adding if you have a lot of related state. useReducer uses a reducer function to update state, which can radically simplify your code because all the state updates can be done in a single function. useReducer accepts both a reducer function and a starting state value. And like useState, it returns an array which includes the state variable and a new function called dispatch. When dispatch is called, it runs the reducer function and sends data to it called an action. The benefit of the action data is to conditionally set state based off of what action came in. useReducer works well for simplifying components with multiple related state values, like multiple inputs within a form. It's also good for components where the state depends on other values, like in this game-based example. This makes useReducer a great choice for apps with lots of user interactions. A state hook you might not have heard of, however, is useSyncExternalStore. This is one of those hooks you're likely not going to use at all. It's primarily used to add non-React state stores into React components, which means you're not going to need it unless you want to make your own state management library from scratch. After state hooks, we have effect hooks, which let us perform side effects. But what is a side effect? It's a way to reach outside React and synchronize with an external system. A good basic example of performing a side effect is to set the title using the document API. To do that, you first give useEffect a function to run, and by default, it'll run after each render. To change that behavior, you can give it a dependencies array. When any value in this array changes, the effect function will run. And when the button is clicked, count will be updated in state, which will cause the effect function to run and update the title. Let's take a look at 2 types of side effects. Event-based side effects, which run when some event takes place, like a button click, and render-based side effects, which is a side effect which runs after render, such as fetching data. And it may surprise you, but useEffect really shouldn't be used for either type. Instead of performing side effects when an event happens in useEffect, make your code simpler by doing it directly in an event handler. And instead of fetching data when your component mounts and putting it in state, use a more sophisticated tool to fetch data like React Query or data fetching patterns that come with frameworks like Next.js. When should you use effect then? You won't need to use it often, but mainly when you need to sync your React code with a browser API, like in this example, where we're synchronizing the React state with the browser media API using a ref and either playing it or pausing it. And in fact, there's a more specialized version of useEffect called useLayoutEffect. While useEffect runs after React paints the UI, useLayoutEffect runs just before React paints the UI. While useEffect is asynchronous, this hook is primarily for synchronous operations that you want to do right before displaying the UI content, like setting state. And this particular use case means this hook is going to be used even less than useEffect. UseLayoutEffect is good to use, for example, when you want to get some initial state from a browser API, like this one where we're measuring the height of a tooltip with getBoundingClientRect, and then setting it in state before the browser repaints and it's visible to the user. UseInsertionEffect is an even more niche effect hook you've probably never heard of, because it's made exclusively for CSS and JS library makers, libraries like Styled Components or Emotion. This hook runs before useEffect and useLayoutEffect run, and it does so in order to make sure any CSS styles are inserted if other effect hooks need to read from the layout. Like effects, refs are a way to step outside of React. The useRef hook is kind of like useState. It lets us remember data, but without triggering a re-render. Like useState, refs can be given any data value, but it's simpler because it returns only one value, which is whatever you passed it. And to access the underlying value, you can use the current property. Another important difference between refs and state is that refs are mutable, while state is immutable. This means the current property can be modified directly using the equals operator. This is really useful in this timer example, where we're storing the interval ID in a ref to clear the interval when we want to using the stop timer function. DOM elements can also be stored in refs. You can do this by connecting a created ref to the ref prop of an element. Once you do that, use the current property to access the underlying DOM element. UseImperativeHandle is a type of ref hook, but rarely used. It's only necessary to use when you need to forward a ref, which means you need to pair it with the forwardRef function, and only if you also need to expose a method to the parent component that passed the ref. Let's say you have a parent component that wants to focus an input within a child component. To do that, you need to first forward the ref to the child with the forwardRef function, which won't be required in React 19. And to expose the focus method to the parent ref, you use UseImperativeHandle to put that method on the ref. UseMemo is one of two hooks made to improve your app's performance. It uses something called memoization to improve performance by caching previous results. UseMemo will recompute the cached value only when one of its dependencies has changed, and this makes it good for performing expensive computations. UseMemo looks similar to useEffect, but it's not for side effects, and it must return a value. A heavy computation that UseMemo might do is calculate the sum of numbers in an array. It only reruns this function when the numbers array changes, and it puts the computed result in the sum variable. Like UseMemo, useCallback memoizes what's passed to it. But useCallback is different. It's for functions, specifically callback functions that are passed down to child components. This improves performance by preventing callback functions from being recreated on each re-render. In this example, we're passing the increment function as a prop to the button component. Since that function updates state, it'll cause a re-render whenever it's run. So to prevent the increment function from being recreated every time the component re-renders, we wrap the increment function in useCallback. There's one context hook called useContext, and it's really pretty simple. It can read context values, which means if a component is wrapped in a context provider, you can use this hook to read the value passed down on context. UseContext works in any component that's nested inside a provider, no matter how deep it is. To read the context value, you just need to pass the created context to useContext, and that's it. In React, all state updates are considered to be urgent. UseTransition is a transition hook that allows us to specify that certain state updates are not urgent. This is helpful for state updates that involve heavy computations, which can lead to a bad user experience if they're executed immediately. We can make our app more responsive by wrapping these state updates in a transition. A great use case for UseTransition is filtering a list based on user input. Typing into the input might cause the UI to freeze or be sluggish, because the app is trying to re-render the list after each keystroke. We can mark the filter state update as non-urgent with the start transition function from useTransition. UseTransition also gives us an isPending Boolean value to tell us when the transition is pending, allowing us to show a loading state to the user until the state update finishes. UseDeferredValue is another transition hook that lets you defer or pause an update to keep your app responsive. It's very similar to useTransition, but we use it to tell React to schedule an update at an optimal time for us instead of us doing it ourselves. To use it, all you need to do is pass the value you want to defer to useDeferredValue. Just like the useTransition example, useDeferredValue is best for things like filtering lists. This leads to the same improved user experience as useTransition, but without you having to manually start the transition or use any pending state. The only reason to use a random hook like useDebugValue is if you regularly use React DevTools. If not, then you probably won't ever use it. But if you do, and you're using custom hooks, useDebugValue lets you label your custom hooks with whatever string value you pass to them. That way you can find your custom hooks easier in the React DevTools extension. UseID is another random hook that does exactly what it says. It creates a unique ID when it's called, and it doesn't require any arguments. But I know what you're thinking. And no, you can't use it to create keys for your list items. It's made for creating dynamic IDs to be shared between form inputs and their labels. UseID is useful when form inputs can be reused multiple times in a single page. In this form component, we're using the email input component twice. So to make sure they each have unique IDs that don't conflict with each other, we use UseID to make a unique ID to keep them separate.